Okay, hello and welcome to Additional Maths Lesson 53, which goes through questions 1 to 10. So it's just part 1 at the moment. We're just doing the first sort of half of this paper, questions 1 to 10 of the 2022 paper, whose the link to this paper is given here. Make sure you've tried the whole paper before watching this and only watch the questions you want a deeper understanding of. Okay, without further ado, let's go on to question 1. So this question, solve this inequality. It's just a higher GCSE question, to be honest. So if you have a good understanding of your algebra at higher GCSE, you should be fine with this question. So we have 3 parts to this inequality rather than 2 parts, but as long as you do the same to all 3 parts, then the inequality still holds. Okay, so if I subtract 1 from the left part of this inequality, then I have to subtract 1 from the middle and from the right. Okay. I'm going to do this in just 2 steps. So we've got 2 lots of x plus 1. If I halve that, I'm just going to have x plus 1 in the center. Okay? Because then instead of 2 lots of x plus 1, if I halve it, I've got 1 lot of x plus 1. So I have to halve the left side and the right side as well. So minus 3 halved is minus 3 halves, or minus 3 over 2, or minus 1.5 if you prefer decimals. I prefer fractions. And 7, if you halve it, is 7 halves, or 3.5, or 3.5. Now, all I need to do is find out what x lies between. We have x plus 1, so I subtract 1 from that, I get x. So I have to subtract 1 from all 3 parts of this inequality. Subtracting 1 from negative 1.5 is negative 2.5, or negative 5 over 2. Subtracting 1 from 7 halves is 5 halves, or 2.5, or 2.5. So x lies between negative 5 halves and 5 halves, which you could show, and that is the solution, and you would get full marks for that. This is only a 3-mark question. It doesn't seem like I've done very much for that 3 marks, but it's a nice 3 marks at the start of the paper. At GCSE, you might want to show that on a number line, so that would be shown by the fact that x lies between negative 2.5 and 2.5. So you would draw a circle above negative 2.5, a circle above 2.5, and join those up. And there would be empty circles because these do not include negative 5 halves and 5 halves. They are both, negative 5 halves is less than x, so it doesn't include negative 5 halves, and x is less than 5 halves, so it doesn't include 2.5 either. Those of you who like modular symbol, you notice that both of those numbers are the negative of each other. You might want to write it like this: the modulus of x is smaller than 5 halves, which means the absolute value of x is smaller than 5 halves, i.e. the distance that x is from 0 is below 5 halves. So it's between negative 5 halves and 5 halves. But I would have just gone with my original answer as the final answer. And there we go, we're done. So the mark scheme shows that it expanded the brackets rather than dividing by 2 first off, but that basically all that does is just gives you an extra line of working. So you could expand and then solve it, but it takes an extra step. And they accept mod x is less than 2.5. So yes, so there's no Barrow Math video to help you with this content. This is a GCSE content, so if you need extra help with this, go and see your maths teacher, I would recommend. Okay, so let's have a look at question 2. Train, 175 meters long, stationary in a station. As it leaves the station, it accelerates with uniform acceleration. That's important, uniform acceleration. So the acceleration is constant. It doesn't change during the journey. When the front of the train reaches the end of the platform, so it doesn't start at the end of the platform, the front of the train the train is stationary and then it speeds up and then it reaches the end of the platform. It's traveling at a speed of 3 meters per second, so it had to have accelerated up to that speed. And when the rear of the train reaches the end of the platform, it's traveling at a speed of 18 meters per second. Determine the uniform acceleration of the train. Well, here in the first part, we're only interested in the period from the front of the train reaching the end of the station, of the platform, to the back of the train reaching the end of the platform. So in that case, our initial velocity we're going to take as when we first reach the end of the platform. So that's 3 meters per second. So u, which is the symbol for initial velocity, is 3. Our final velocity, which is when the back reaches the end of the platform, is 18 meters per second. And the distance traveled in that time, because from the front of the train reaching the end of the platform to the back of the train reaching the end of the platform, the train would have, because it's 175 meters long, that distance that's traveled so far is 175 meters. Because when the back of the train reaches the end of the platform, the front of the train will be 175 meters further ahead. Okay. So we've got those three values. So we're using the suat equations, of which in each of the suat equations, they focus on 4 of those letters, S, U, V, A, and T. And if we have 3 of them, then we can find the 4th. So we're looking for the uniform acceleration. So we're looking for A. So we're looking for the suat equation, which involves U, V, S, and A. And that is V squared equals U squared plus 2AS. And all we need to do is substitute the values we've got and then solve to find A. So V squared is 18 squared, which is 324. U squared is 9, because 3 squared is 9. 2AS, well, 2 times A times S is the same as 2 times S times A. And 2 times S is 350, so that will be 350A. And now we just solve to find A. We subtract 9 from both sides of this equation, and then divide by 350, and we get A is worth 0.9 meters per second per second. Okay, so that's the uniform acceleration of the train. Okay, so that's our final answer for part A. Part B, determine the time taken from when the train starts to move. So this is before it reaches, the front reaches the end of the platform. So when the train starts to move, all right, so it starts from stationary. It says that in the start of the question. All right, it's stationary in the station. So then U is 0 until it reaches a speed of 18. Okay, so V is 18. And we also know, because there's uniform acceleration, and we've just found that out, that A is 0.9. So we've got 3 things, and we want to find the time taken. Okay, and to find the 4th. So we just need a suat equation, which involves U is 0, V is 18, A is 0.9, and we want to find what T is. Okay, so you're looking for the suat equation, which involves U, V, A, and T. And that one is just V equals U plus AT. The final velocity is the initial velocity plus the acceleration multiplied by the time. And so we just substitute values in. So V is 18, U is 0, A is 0.9, and we solve that. So we divide both sides by 0.9. And to find T, so T is 18 divided by 0.9, which gives us 20 seconds. There we go. So that is the answer to part B. And if we look at the mark scheme, yeah, they have the same idea. V squared equals U squared plus 2AS for the first one, finding 0.9, and V equals U plus AT to find T. Okay. And in part B, if you'd gotten the wrong answer to part A, you could still get the full marks, because you followed through your answer to part A, and so you can get the method mark and the accuracy mark if you have used it correctly in part B. If you need any more help with this, you can go to the suat constant acceleration formulae video on Barra Maths, video number 45. Okay, question 3. So a photograph is to be taken of 9 students who have represented their college in sailing this year. The students are to be arranged in a line. This is sounding like a permutations question. The captain is to stand in the middle, with the vice captain standing beside the captain. Okay, it doesn't say which side of the captain the vice captain is standing. Okay, but the captain is definitely to stand in the middle. Okay, so the captain is fixed. The vice captain could be either side of that fixed position, and then everyone else How many ways are there arranging the students? Okay, so I'm thinking of, I would start visualizing the problem. Okay, so I have 9 spaces. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spaces to fill. And I know that the captain is right in the middle. So that's the 5th space of the 9, 4 either side. So the captain is right there. So there are two different options because it tells me the vice captain stands beside the captain. So option 1, so I'm going to call this option, let's call it option A. You've got the vice captain on the left side of the captain, looking at them. And then you've got option B, where your captain is fixed, but your vice captain is next to them, but on the other side. Okay. So in effect, we've got 2 options here, and in each of those options, you've got 7 more spaces to fill. And those 7 spaces can be filled in 7 factorial ways. Because if we just choose someone to fill this first spot, we've got 7 choices for that spot. And then we've got 6 people left to choose for this spot, and then 5 people left for that spot. 4, 3, 2, 1. So it's 7 times 6 times 5 times 4 times 3 times 2 times 1 ways of filling in the rest of the gaps. So we have 7 factorial ways of arranging those 7 people for option A and for option B. So there are 2 different versions of 7 factorial. Okay, the one with the vice captain on the left, one with the vice captain on the right. So it's 7 factorial multiplied by 2, which is 10,080 different ways. And there is your answer. So with these questions, I always like visualizing the problem. So drawing out the spaces and trying to see what constraints I have and trying to see how many different options I have for those constraints. Okay, let's have a look at the mark scheme. It just says, 7 factorial for the people to be arranged other than the vice captain and the captain. And the vice captain, there are 2 options, can stand on either side, so times by 2. Okay. If you need more help with permutations, video 21 on Barrow Maths is where to go. Question 4. Okay, I like it when it does this. In this question, you must show detailed reasoning. Okay? So you cannot get the marks just for a final answer. You have to show the steps and the argument, the mathematical argument that leads you up to that final answer. Especially in part B. I mean, part A, there's 1 mark. It's probably going to be one thing that they want to see. Part B, 4 marks. They want to show the detailed reasoning that leads you to the answer. The reason for that is because in this question, solving a cubic, some of you will have calculators that can just do that straight away. You can just type in a cubic and it will tell you the solutions, the roots of the equation. So that's why they want you to show detailed reasoning, to show that you have the skills to be able to do it without that calculator. Okay, part A, show that f of 1 equals 0. That's a relatively simple thing to do. F of 1 means substitute 1 in instead of x. So instead of the input x, you have an input of 1. So f of 1 equals, we know it's going to equal 0 because it says show that f of 1 equals 0, but we have to detail how it's got there. So we're replacing x in this formula with 1. So we've got 1 cubed plus 6 lots of 1 squared plus 5 lots of 1, take away 12. So we find all those out very carefully. 1 plus 6 lots of 1 squared, so that's 6 lots of 1. So that's 6 plus 5 lots of 1, so that's 5. Subtract 12, and that equals 0. QED. You don't have to write QED, I just like writing it. It's a Latin phrase, quod erat demonstrandum, which means basically this is what I wanted to find, which is what was wanted to be shown. So in a show that question, I like writing QED at the end. It means I've reached the point at which I have shown the thing that wanted to be shown. Part B, hence solve the equation. Ah, lovely, hence. So don't show it in any other way, hence. So using your answer to part A, solve this equation. Okay, well, part A has shown us something very important. f of 1 equaling 0 means I have now found a root. So 1 is a root of the equation, which means if I have a root, I have a factor. So if 1 is a root, then x minus 1 is a factor. That is the factor theorem working. Okay, so if f of 1 equals 0, that implies, and is implied by, so it works both ways, that x minus 1 is a factor. Which is great. If I've got a factor, I can now do some factorization of the cubic to try and find other factors. So I like doing it by dividing using a grid. So x minus 1 multiplied by what? So it'll be multiplied by some sort of quadratic will give me the cubic solution. So I know in the top left here, I'm going to have x cubed. How do I multiply? What do I multiply x by to get x cubed? So that's going to be x squared. X multiplied by x squared is x cubed. So let's fill in what we can. So negative 1 multiplied by x squared is negative 1x squared. In my cubic, I want 6x squared. I don't want negative 1x squared. So I need another 7x squared, so that together these two terms will combine to make 6x squared. Which means up here I need 7x, because 7x multiplied by x will give me a 7x squared. So I can fill in a little bit more. Negative 1 multiplied by 7x is negative 7x. I don't want negative 7x, I want positive 5x. So I need another 12x, because 12x and negative 7x together will combine to make 5x. Which means the top here is 12. 12 multiplied by x is 12x. And 12 multiplied by negative 1 is negative 12. And let's just check that that's what I wanted. Yes, negative 12 is part of the function. Okay, so I have now factorized the original function into a linear factor and a quadratic factor. So let's write down what we've got. We want to solve the equation f of x equaling 0. So we want to solve the equation where x cubed plus 6x squared plus 5x minus 12 equals 0. And we've got x minus 1 multiplied by x squared plus 7x minus 12 equals 0. So we've started factorizing it. And now let's continue factorizing. Let's factorize that quadratic. So x squared plus 7x minus 12 factorizes into, oh, sorry, I don't mean plus 12, minus 12, I mean plus 12. Because there's a positive 12 there. There's the negative 12 at the end, sure, but that's only because you multiplied positive 12 by negative 1. To factorize x squared plus 7x plus 12, you get x plus 4 and x plus 3. So I now have 3 factors of my cubic, and hence I have 3 roots. So my solutions are x is either 1 or negative 4 or negative 3. And those are my 3 solutions. Okay, let's have a look at the mark scheme. So first mark, just plugging into f1 into the function, great. And for part B, as we've said, some sort of method to factorize the thing. Some people might use long division. I prefer using the grid. There is an alternative method of answering this question, which is the use of factor theorem to find all roots, which is essentially trying different values into the function and seeing which ones give you 0. Just like in the first part, you tried 1 in and it gave you 0, therefore x minus 1 was a root, was a factor, and 1 was a root. Okay, if you need more practice on this, on the factor theorem, video 4 on Barrow Maths is where to go. Okay, next question. So question 5. In this question, you must show detailed reasoning. Another one of those. Fantastic. Find all the values of theta in the range from 0 to 360 that satisfy the following equations, giving your answers correct to 1 decimal place. Okay. 3 marks and 5 marks. Okay. Part A, cos of 2 theta is 0.6. So whenever I get a question like this, where I've got cos of, and it's not just theta, it's something more complicated. I like thinking of it as, okay, I might ask me for something more complicated, but I'm just going to make it simple. I'm just going to answer the question, cos of something equals 0.6. I'm going to call it just cos of A is 0.6. I'm going to find solutions for cos of A is 0.6. I'm going to find all the answers for A there. So A has replaced 2 theta. Okay. So if I wanted theta to be between 0 and 360, then 2 theta has to be between 0 and 720. So I want to find all the answers for A between 0 and 720. And once I've done that, then I will convert them into theta by dividing them all by 2. Because theta is half of A, if A is double theta. Okay, so this is a simple trigonometric equation. There's not much going on in it. It's simply a cosine function equaling 0.6. So what I would do is I would sketch out the cosine function within the range that I want. So I want to sketch it out between 0 and 720. The cosine function starts at pi, at 1. So that's one full turn of the function. So that's 360 degrees, but I need another full turn of the function. So that's 720. Okay, and 360 there. And then what I do is I try and mark off 0.6. So 0.6 on my scale. Usually I'd like a little bit more paper for this. 0.6 on my scale is there. So there should be quite a few different answers for 0.6. Here's one, and my calculator will help me get that. Here's another, which is nicely symmetrical. And I can find that using the symmetrical properties of the graph. Again, that one, 3, and here's the 4th answer. So those are 4 different values that I'm going to get by using my calculator to help me solve. So my first answer, this one here, I'm going to find A by doing inverse cos of 0.6. And my calculator gives me for that 53.13 and keeps going forever. Okay, so that value there is 53.13 ... So with that, I can find all the others. The distance here is exactly the same as the distance here. So they are symmetrical. And therefore, if I wanted to find the value that's here, all I need to do is take away 53.13 from 360 and I'll get that. It's also the same as the distance here. So I can add 53.13 to 360 and I'll get this third value. And it's also the same distance here. So I can take away 53.13 from 720 to get the 4th value. So those distances, because this graph is symmetrical, are easy to find because I've found it already, 53.13. And I just need to think about using the graph where I'm going to add and subtract that 53.13 from. So I now have that A could be 53.13 ... I'm not going to write a rounded version of that because I don't want a rounded version. I want what's on my calculator because I haven't found theta yet. I haven't found the final answer. I found A, which is double theta. So that's the first one, 53.13 something degrees. And then the next one, 360, take away that is 306.869 ... degrees. Next one is 413.13 ... degrees. And the last one was 666.869 ... degrees. Okay, so that's the values of A, the 4 values of A that we've got from that graph. And therefore, if I want theta, since A is double theta, so 2 theta is A, then if I want theta, I just halve those. And this time I will round to 1 decimal place because that's what the question asks. So 26.6 degrees, 153.4 degrees, 206.6 degrees, and 333.4 degrees. All of those to 1 decimal place. Okay, so that's part A done. So the key thing there is I like finding all the answers for the double angle, so for t theta, before I divide by 2. A common mistake people make is finding 53.13, dividing it by 2, 26.6, and then trying to look at the graph and saying, oh, I'll take it away from 360. But that won't give you the right answer. Okay, 360 to equate 26.6 does not give you 306, etc. Okay, so find all the double angles first and then divide by 2. Part B. Solve this lovely quadratic trigonometric function. 12 cos squared theta plus sine theta equals 11. In order to find the answer to this, I need to use a trigonometric identity. So I need to use the fact that I know that cos squared theta plus sine squared theta is always equal to 1. That is an identity. That is always true. And therefore, if I wanted to rewrite cos squared theta, I could always rewrite it as 1 subtract sine squared theta. And that's going to be immensely helpful here because I have a quadratic equation with trigonometric functions that have 2 different variables in effect, cos theta and sine theta. I want it just in 1 variable, okay? So if I replace cos squared theta with 1 minus sine squared theta, I then have it all in terms of sine theta, and therefore I have it all in terms of 1 variable, and I can work my quadratic magic on it. So I'm going to use the fact that cos squared theta is 1 minus sine squared theta to replace cos squared theta. Okay, so I had originally 12 cos squared theta plus sine theta equals 11. I now replace the cos squared theta with 1 minus sine squared theta. So I get 12 lots of 1 minus sine squared theta plus sine theta equals 11. Multiply out the brackets. 12 minus 12 sine squared theta plus sine theta equals 11. Now this is essentially a quadratic equation. Solving a quadratic equation is useful if I have an equation equaling 0. I like having a positive amount of the squared function. So I'm going to add 12 sine squared theta. So I'm going to make the left side 0 by subtracting 12, adding 12 sine squared theta, subtracting sine theta, and I get this. So 0 equals 12 sine squared theta minus sine theta and minus 1. Because the 11 take away 12 is negative 1. Then factorize. So here I know if I'm going to try and factorize this, that I might have 12 sine theta at the start of one bracket and sine theta in the other. But I know for sure I'm going to have positive 1 and negative 1 at the end. To multiply to make negative 1, I need 1 times negative 1. I mean, it might be more complicated than that, but it's likeliest to be that because I want to just focus on whole numbers if possible, if I can factorize. If I can't factorize, then I can use other methods like the quadratic formula, but I'll try and factorize first. In order to combine to make negative sine theta, it's likely not to be 12 sine theta and sine theta. It's more likely to be the things which are 1 apart. So 4 sine theta and 3 sine theta. Let's just see if I've got it the right way around. 4 sine theta times 3 sine theta is 12 sine squared theta. 4 sine theta times negative 1, those two will make negative 4 sine theta. 1 times 3 sine theta is 3 sine theta. And negative 4 sine theta add to 3 sine theta is negative sine theta, which works. So great, I've got the right factorization, so I'm happy there. As a result, then I know that sine theta, because from one of these brackets, from this one here, in order to make that bracket equaling to 0, then sine theta needs to be negative 1/4. For this bracket to make 0, then sine theta would have to be positive 1/3. So I have two possible routes to my answers. So I want all the answers from between 0 and 360 for theta, for which both of these things are true. Okay, so the next thing I do is I sketch the sine function between 0 and 360. So sine theta, sine of 0 is 0. So I'm going to sketch it like this. There it is between 0 and 360. There's 180. There's 360. And I want to know all the values that I can get where sine theta equals negative 1/4. So negative 1/4 is here. So that's going to give me two solutions, one just above 180 and one a similar distance below 360 that this is above 180. The same distance below 360 that this is above 180. And I want solutions also from sine theta equals 1/3. So sine theta equals 1/3. 1/3 is around here. And I'll have one solution here and another solution here. And again, that distance will be the same as that distance. Okay, so my calculator, I'll do the third one first. Sine to the minus 1 of 1/3 gives us theta is 19.47 ... So 19.5 degrees to 1 decimal place. I'm not going to be doing any further calculations, so it's okay to round at this point in time. And therefore, the other value from 1/3 is 180, take away the 19.47, etc., which is 160.5 to 1 decimal place. So those are the two solutions from that. The negative 1/4 is slightly more complicated because on the calculator, when I do sine to the minus 1 of negative 1/4, it actually gives me a negative angle. The reason is because the closest angle that gives it is not the one which is above 180. It's the one below 0, which is this angle here. So that gave us negative 14.477. That angle there, negative 14.477. So really the distance left there is 14.477. So the distance to the right of 180 will be 14.477. The distance to the left of 360 will be 14.477. And so all I need to do is do 180 plus 14.477 and 360 minus 14.477, and I've got my answers. So theta is 194.5 to 1 decimal place and 345.5 to 1 decimal place. And those are my 4 solutions. So let's have a look at the mark scheme. Okay, and there you go. If you need more work on this, the trigonometric equations 1 video, the trigonometric equations 2 video, the trigonometric identities video, which are videos 14, 16, and 17, are places to go. Okay, let's have a look at the next question, question 6. Okay, the traffic lights question. Okay, so this one here is just a GCSE content video. GCSE content question, so it has no Baromaths video. And so I'll skip through it quite quickly. So Layla drives to work along the road, 3 sets of traffic lights. The chance she has to stop is 0.5, 0.6, and 0.7 respectively. They work independently of each other, which means that they do not affect the chance of her stopping at a future traffic light. Okay, so whatever happens in a previous traffic light, the probabilities will stay the same for future traffic lights. Draw a tree diagram to illustrate the probabilities of light Layla having to stop. Okay, so first set of traffic lights, she either stops, S, or she doesn't stop, and I will do S dash for that, which is the complement of S, which is the probability of it not happening. Okay, and the second set of traffic lights, stop or not stop, stop or not stop. And the third set of traffic lights again, so there end up being 8 possible options, which is 2 to the power of 3, because you're splitting it up into 2 different options at each point over 3 successive events happening, which is the 3 different traffic lights. And then you've got to put the probabilities on. First set of traffic lights was 0.5 she stops, so it's 0.5 she doesn't stop. The next one was 0.6, so it's 0.4 she doesn't stop. And then the third set of traffic lights was 0.7 she stops, so it's 0.3 she doesn't stop, etc. And that is all the marks. That's 3 marks for just drawing that. Part B. Calculate the probability that Layla has to stop exactly once on a particular journey to work. Okay, so all we need to do now is isolate the different branches which lead us to her stopping exactly once. Okay, so that would be, if she stopped on the first one, then she must have not stopped on the next 2. So that would be exactly once. Or she stops only on the second one, which would be this probability. Or she only stops on the third one, which is that one. To find the chance of these things happening is multiplying along the branches, because you have, for example, if we focus just on this branch, then you've got a 50% chance of it heading down stop in the first one, a 40% chance of the not stopping at the second one, which is 40% of the 50% of the time, and then 30% chance that you don't stop at the next set of traffic lights. So it's 30% of the 40% of the 50% of the time that happens. And if you multiply those, you get 0.06. So 0.06 chance of that happening. And similarly with the others, so 0.09 and 0.14. So any of these could happen, and they will end up with exactly 1 stop. And so the sum of those is the answer to part B. So you should probably show all your workings for the 3 marks. So I would write down 0.5 times 0.4 times 0.3 plus, and then the other one, 0.5 times 0.6 times 0.3, and then plus 0.5 times 0.4 times 0.7. And that equals a sum of 0.29. So 29% chance that happens. Okay, so look at the mark scheme. There we go. Not much to talk about there. So no Barrow Maths video for that. All right, question 7. A local council investigated the pattern of a travel to a nearby town in 1 month. Okay, so it gives you some answers of what they did. Here are the results. The total number of residents surveyed was 60, okay, which is not the sum of those values, because it says some of the results, and also there might be, and it talks about this as an incomplete set of data as well. All right, so draw a Venn diagram to illustrate this incomplete set of data. I'm going to draw it just right here next to it so I can see everything very clearly. So there are 3 modes of travel, some of them intersecting with each other, because it says some people used all 3 modes, some people used 2 of the modes and not the other one. So I'm going to show 3 intersecting circles. It's very interesting when you try and get 4 intersecting things. They rarely ask that because it's very complicated to draw. Google it if you want. So Venn diagrams with 4 and more sets. I love the one with 7 sets, but that's something you can do in your own time. So I'm going to label them. So walked, cycled, and drove. So 15 only walked, so did not use either of the other two, so that would be in there. 9 only cycled, so that would be in there. 12 only drove, so that would be in there. 4 used all three, so that would be in the intersection of all three. And 6 walked and cycled, but did not drive, so that would be in there. Okay, so there are 3 gaps. The people who did not do any of those 3, and then the people who walked and drove but did not cycle, and the people who cycled and drove but did not walk. Okay, we've got our 3 marks because we've drawn the Venn diagram to illustrate the incomplete set of data. The number that said they drove and walked but did not cycle, drove and walked but did not cycle, so that's this bit, was the same as the number that said they drove and cycled but did not walk. So that's this bit. So I'm just going to call them both X. All those surveyed said they had travelled to the nearby town by one of these 3 modes of transport at least once. Okay, so that's easy. That means that this outside is 0. None of the 60 did not use any of those 3 modes, and therefore that's 0. Determine how many of these residents drove and walked but did not cycle. Well, that's relatively simple. We know there are 60 in total, and we just have a very simple equation to solve. So 3 marks does seem a little bit easy for this, but hey, we'll take our marks where we can. So 2x plus all those values equals 60, and then solve that equation for part B, which leaves you with, I believe, x is 7. Okay, so 2x has to be worth 14 because all those numbers there add up to 46, and therefore you have 14 left, shared between 2, so they are 7. So part B, x is 7, full marks. Let's have a look at the mark scheme. It's almost strange thinking this is 6 marks picked up in this exam. You would be very happy if that was at the start of your GCSE paper, I imagine. Okay, and there's no Maths video for this. It's relatively simple, so let's leave that behind. And let's move on to question 8, which I believe will hopefully be a bit more challenging. Okay, question 8. The gradient function of a curve. Oh, fantastic. We're getting on to calculus here. The gradient function of a curve is given by dy by dx, the change in y over the instantaneous change in y over the instantaneous change in x, is 2 plus 4x minus 3x squared, and the curve passes through the point 1, 2. Determine the equation of the curve. So this is a classic integration problem. So if you go from the gradient function to the curve, you are integrating. If you're going from the curve to the gradient function, you are differentiating. So to find y, we need to integrate this function 2 plus 4x minus 3x squared with respect to x. What that gives us, 2 integrates to 2x to the power of 1, because it was 2x to the power of 0, and it's increased to the power of 1, and we divide by 1, so it just becomes 2x. 4x becomes 4x squared divided by 2, which is 2x squared. And minus 3x squared becomes minus 3x cubed divided by 3, which is just minus x cubed. And we also have a constant that we don't know. Okay, so y equals that. And then we are given this coordinate 1, 2 that it goes through, therefore we can find c. So we can substitute instead of x, 1, and instead of y, 2. So 2 is equal to 2 lots of 1 plus 2 lots of 1 squared minus 1 cubed plus c. And therefore, if we evaluate that, c is negative 1, and therefore y equals 2x plus 2x squared minus x cubed minus 1. Ta-da, all done. We have our equation for the function, and we have evaluated c. 4 marks, lovely. Nice simple bit of calculus there. If you want a little bit of practice on integration, this is the first part of integration, integration 1, video 40. So have a go in your own time. Okay, question 9. 2 questions to go in this part of the video. Okay, logarithms question, lovely. In this question, you must show detailed reasoning. Okay, fantastic. So you're given that y equals 4 multiplied by log base 3 of x. Rewrite this equation with x as the subject. Okay, so I'm immediately thinking of 2 different first steps. So I'm going to show 2 different ways of doing this question. Okay, so option A, I'm going to divide both sides by 4. So I'm going to get y divided by 4, or a quarter y, equals log base 3 of x. What I want, if I wanted to rewrite an equation without a logarithm, is I want the logarithm on its own. I don't want something multiplied by the logarithm. I just want the logarithm itself. Here I've got log base 3 of x. So I have the logarithm by itself. The inverse of log base 3 of x is 3 to the power of. So if I put both sides as 3 to the power of those sides, then the left side becomes 3 to the power of y over 4. And the right side just becomes x, because 3 to the power of log base 3 of x is just x. And there we go. X is the subject. I mean, I could rewrite it as x equals 3 to the power of y over 4, but you get the idea. The other way, I could have used a log law to rewrite that. So I know one of the log laws is n log a is log of a to the power of n. Those are equivalent expressions. So I could write 4 log base 3 of x as log base 3 of x to the power of 4. So I know that y equals log base 3 of x to the power of 4. And now, again, here I've got just a logarithm of something. So if I do 3 to the power of both sides, 3 to the power of the left side becomes 3 to the power of y. 3 to the power of the right side will just give me my x to the power of 4. And then I've just got one step. I need to do the 4th root of the right side to get x. So I need to do the 4th root of the left side. So the 4th root of 3 to the power of y equals x. And I'm done. And you might be thinking, well, those look different. Well, they're not. They're exactly the same, because the 4th root means to the power of a quarter. So 3 to the power of y to the power of a quarter, when we do power to a power, we multiply them. Y times a quarter is y quarters, or y over 4. So these 2 different ways of getting to the answer look different, but are exactly the same. Okay, part B. Write 2 log base 10 of 5 plus a half log base 10 of 16 as a single number. Well, it looks like we're going to be using our log laws to combine different logarithms. To add different logarithms, that's one of the log laws. But before I do that, I need to have just log of something plus log of something. So I'm going to be using this log law first to change it when it's multiplied by something to turn it into a logarithm with a power instead. So 2 log base 10 of 5 is the same as log base 10 of 5 squared, or log base 10 of 25. And again, half log base 10 of 16 is log base 10 of 16 to the power of a half. Power of half is square rooting. So that becomes log base 10 of 4. So I've got log base 10 of 25 plus log base 10 of 4. Now I can use the logarithm law, the first logarithm law, which is log a plus log b is log of ab. So that becomes log base 10 of 25 times 4, which is log base 10 of 100. And log base 10 of 100 is simply 2, because what power of 10 gives you 100? That is 2. And there we go. We've written it as a single number. Okay. Part C. The equation a to the power of x is 17 has the solution x is 2.58, correct to 3 significant figures. Given that a is an integer, determine the value of a. Okay, I'm thinking of various different ways of solving this. Okay, let's think about it. Firstly, let's try and I'm thinking we could do trial and error. I'm thinking we could use our logarithms. Okay, so we have a to the power of x is 17. I'm going to start just by using logarithms, see if that's one way. So I know if I take logarithms of both sides, I don't know what a is, so I can't take a specific base yet. I'm going to do base 10. So when I write log, it's just log base 10, because that's the most common base, because our number system is based around the number 10. So log of a to the power of x is log of 17. Okay, and then I can use the log law to bring x out of the logarithm. So x multiplied by log a is the same as log 17. So log a, because a is what I want to find, log a is log 17 divided by x. And to find a, all I need to do is do 10 to the power of both sides. So this log 17 over x will give me a value, because log 17 is just a number, and x is 2.58, correct to three significant figures. So if I do 10 to the power of the answer, then I'm going to approximately get a. 10 to the power of the answer on my calculator, which is log 17 over x, gives me approximately 2.9985 ... So it looks like a is 3. So that's one way, is just using the values you've got and seeing what's the closest number to the answer you get. I mean, you could just do it by trying different values out, seeing, you know that x is 2.58, so you know it's a to the power of 2 point something, something between 2.575 and 2.585, because that's the limits of accuracy. So I could just try, so if I just write a to the 2.58 is approximately 17, and I try different values. I mean, I could just try, I know it's a whole number because it told me that. So 2 squared is 4, 2 cubed, because the 2.58 is between 2 and 3. 2 cubed is 8. It's not going to be 2, because that's going to be too small. I could try 3 squared and 3 cubed. 3 squared is 9. 3 cubed is 27. So that looks much more likely, because 3 to the power of 2 point something will be 17. And if I try 4 squared is 16 and 4 cubed is 64, that is very unlikely, because 16 means that if I do 4 to the power of 2 point, and it'll be a number very close to 2, 4 to the power of 2.1-ish would be 17. So it's unlikely to be 2.58. So it seems that a would be 3 from trial and error. And you could even do the 2.58th root of 17 on your calculator, because if you've got a to the power of 2.58 is 17, then a would be the 2.58th root of 17, approximately, which on my calculator gives me 2.998 ... So it looks like a is 3 using that. So lots of different ways we could get the fact that a is probably 3. Let's look at the mark scheme. So yeah, they went through the first answer I did, and the second one, and sorry, the third one and the second one, trying different values and seeing which one to choose. It's only 2 marks, so it allows that. If you want to practice logarithms 1 and 2 videos, 27 and 28 are the ways to go. Right, last question, question 10. In this question, you must show detailed reasoning. We love our detailed reasoning. So 2 curves have the following equations. Curve 1 is y equals x squared minus 4x plus 4, a positive quadratic. And curve 2 is a negative quadratic. Part A, find the coordinates of the 2 points of intersection of these curves. Okay, let's just solve simultaneously. So let's do that. Let's solve these two simultaneously. So we've got y equals one of them and y equals the other. So let's just make the two y's equal to each other. So let's just erase that. So that again. So x squared minus 4x plus 4. We're interested in, because that is what y is equal to. And y is also equal to, in the other equation, negative x squared plus 8x minus 6. So we're interested in when those two are equal. So let's turn it into a quadratic. Well, it is a quadratic, but turn it into a quadratic equaling 0 to solve it. So I'm going to add x squared to both sides. So we get 2x squared. I'm going to subtract 8x, so minus 12x. And I'm going to add 6 to get positive 10 equals 0. I could solve straight from here. I could use my calculator to just find the roots. I'm going to divide everything by 2 because everything has a factor of 2. So we've got x squared minus 6x plus 5 equals 0. Slightly easier to factorize now. So we have x minus 5 in one bracket. That's one factor. And x minus 1 is another factor. And therefore, my two roots are x is either 5 or x is 1. And with those two values of x, I can find values of y. So y is either 9. When x is 5, y is 9. I simply substitute 5 into either of the equations. I will get 9. And when x is 1, y is 1. So my solutions are 5, 9, and 1, 1. Okay, those are the 2 points of intersection of the curves. Part B, find the area of the region enclosed by the two curves. Ooh, nice. I really like sketching these problems out. So I'm going to just do a little bit of algebra just to help me sketch them out. I'm going to rewrite the first equation in completed square form. So that's just x minus 2 all squared, and that's it. And the other one is, if I take a factor of negative 1 out of minus x squared plus 8x, then I get negative of x squared minus 8x. And so x squared minus 8x becomes x minus 4 all squared. If I expand that out, I would get x squared minus 8x plus 16. And if I do the negative of all that, I get negative x squared positive 8x and negative 16. So I need another positive 10 to make negative 6. So that completed square form helps me give the vertex of the curves. The vertex of the first curve is the point 2, 0. And that is a minimum point because it's a positive quadratic. Okay, so it's a U shape. And the vertex of the second curve is a maximum, and it's at the point 4, 10. And that's an N sort of shape, a hill sort of shape. And that just helps me sketch it out. So I'm going to sketch the function out. I'm only interested between 1, 1 and 5, 9, really. So I'm going to sketch it out like so. So 1, 2, 3, 4, 5. And let's make it so that the y-axis, each of these is 2, 4, 6, 8, 10. And I'll do my first graph in green. So the x minus 2 all squared, which will go through at 4. Minimum point at 2, 0. And it'll go through at 5, 9 because that's the coordinate where they meet. There we go. And the other one goes through at -6, which is not really on my graph, but it goes through at 1, 1 where they meet. So if I draw this one in orange or a different color, let's choose red. Let's choose orange. Let's do that. So we will have a maximum point at 4, 10. So we're looking for that as a maximum. And it'll go down through, our point there, 5, 9. Okay, so what we're looking for is the region, the area of the region between the graphs. So this shaded region here is what we're looking for. Okay. And we have y equals the positive quadratic x squared minus 4x plus 4 as one of the graphs, and we have the orange graph y equals negative x squared plus 8x minus 6. So the graph that's above throughout that region is the negative quadratic, and then the graph that's below is the positive quadratic. To find the area between two curves, the best way of doing that is find the integral of the difference between them, because when you're doing the integral, we're doing the sum of all the y values in a certain region. So if I want the sum of all these red lines are the differences between the two graphs. So that's the orange graph minus the green graph is the difference between them. So that's what I want to do the integral of. I want to do the integral of the orange graph minus the green graph, the difference between the two. So the area is the integral between 1 and 5 of one graph minus the other. So the top graph is the negative quadratic. So negative x squared plus 8x minus 6. Subtract, and I'll put this in a bigger bracket, subtract the other one, x squared minus 4x plus 4 with respect to x. So simplify that first before you do the integration. It makes it a lot easier rather than having to integrate lots of different algebraic terms. So if I simplify it, I get the integral between 1 and 5 of, so negative x squared, take away another x squared is negative 2x squared. 8x subtract negative 4x is positive 12x. Negative 6, take away 4 is negative 10. So now I get to do my integration. So I integrate each of these terms. And put it in square brackets. So negative 2x squared becomes negative 2x cubed over 3, so negative 2/3 x cubed. 12x becomes 12x squared over 2, so that's positive 6x squared. And negative 10 becomes negative 10x to the power of 1 divided by 1, so just negative 10x. And then I've got my limits 1 and 5. So I now substitute 5 in, and I substitute 1 in into those terms, and I subtract the answers from each other. If I substitute 5 in, I get in total 50/3. If I substitute 1 in, I get negative 14/3. So I'm doing 50/3 minus, so 50/3 subtract negative 14/3. And that gives me 64/3, which is my area, or 21 1/3 units squared. So this is an area, so we say units squared. Okay, let's have a look at the solutions and the mark scheme. Okay, part 1, just as we did it. Part 2, that's how we did it. So subtracting the two curves from each other and then integrating and then plugging in 5 and 1. They got I think they've done a slightly different way of calculating to get those. I think I would ignore that. Okay, but 64/3 is the answer. And they've got an alternative method, which is finding the area under one of them between 1 and 5, and then finding the area under the other between 1 and 5, and then subtracting them. That is a long way to do it. Lots of different integration and substitution. I would find the difference between the two curves and integrate that. It's a much better way. If you need more practice on this, that's the area between two curves video, which is video 44. And that is the end of part 1 of this sequence of videos. I will do questions 11 to 15 in a different video. Okay, so make sure you have a go at all the questions yourselves, remember, before you go through the answers. Okay, all the best.